Hey everyone, welcome back to our Application Academy and the PR.Stability Analysis software tutorial series. Again, my name is Lindsay Dawson and I'm an application specialist with Nanotemper Technologies. In this tutorial, we're going to be presenting a really great feature of the software that is meant to help expedite your data analysis when looking at more complex unfolding profiles. Now, we know when working with these types of samples that it can be very tedious for you to go sample by sample to ensure that all of your inflection points were captured by the PR Therm Control software. And what I'm referring to when I say a complex unfolding profile, a nice example would be when we have a smaller peak that appears as a shoulder to a primary peak. Given what you know about your protein sample, you know that that shoulder peak is actually reflective of a domain unfolding event and should be assigned an inflection point value. We now have a solution built into the stability analysis software specifically meant to help deal with these types of data sets. This is now our region of interest option that's built into the software, which we can select for and apply to a given region to evaluate and capture all of those inflection points that may have been missed. Let's go ahead and jump into the software and see how this works. Okay, so to apply the region of interest analysis to our data set, we first need to tell the software in which region it should look to fit the data. We then need to select the type of fit that needs to be applied, either a 2-state or a 3-state fit. Now we're looking at a 2 unfolding transition example, so we're going to select the 3-state fit to be applied. So we'll first click on Add Region of Interest and select our fit type. We can first click on where we'd like the region of interest to start and then click on where we'd like it to end. Now the software will apply this 3-state thermodynamic fit to our data. And what we can notice is a new pop-up of region of interest that displays underneath the data table. This we can then use to evaluate further the additional replicates that we have in a data set simply by clicking on one of the replicates and select Evaluate Selected. So that's going to go ahead and apply the same evaluation to the various replicates in this data set. Now, looking at the data table, we have our original inflection point values, and as we scroll over to the right-hand side, we can now see that we have new parameters displayed as TM1, TM2, as well as the slopes and initial values. Now, it's completely appropriate for us to label these as melting temperatures versus inflection points because we've now fit a thermodynamic model to our data to directly calculate these melting temperatures. So this is a really big advantage that the software now allows you to directly extract these thermodynamic parameters from your data, and it can be applied to the entire data set simply by selecting these regions of interest. So the last thing I'd like to highlight is that these regions of interest can then also be saved again as analysis templates to be used in the future when looking at similar samples. And this is again meant to help expedite and standardize your analysis workflow in the future so that when you're working with these samples that have these more subtle transitions that aren't always picked up by the software, you can simply apply this same region of interest analysis to the data and carry out the analysis and quickly obtain your TM information. I hope you found this tutorial helpful. As always, let us know if you have questions, and please check out our Explorer community and join your fellow PR users to interact and ask questions. Thank you.